Welcome to another unit in this Excel course. This time I'm going to talk about measures of distribution. So in particular, skewness and kurtosis. Well, first off, we can start with the skewness. Skewness describes whether we have more smaller or more larger values. So if I have more smaller values, I'm also calling this rightward skewed. If I have more larger values, I'm calling this leftward skewed. And well, how do we actually achieve this, calculate this? Well, for this we have the so-called skew function. With difference here, we have skew and skew p. Skew is more or less again as with the variance and the standard deviation, the corrected version, whereas p is the uncorrected version. So here we're going to use the normal skew based on this data set. And we get a value of 0.16 or 17. Here it's important to note whether this value is positive or negative. If this is positive, here in this case, we have actually rightward skewed data. If it were negative, we would have leftward skewed data. So rightward skewed data meant we have more small values than large values. So in other words, we have rather more people with better marks than people with worse marks. But it's not as severe because it's relatively close to zero. So that's what we can use the skewness for. Find out if it's, well, skewed in one direction, more smaller, more larger values, where it's leftward skewed, smaller, rightward skewed, larger values, which are overproportionally strong. Okay, so this was the skewness. Then the next part is the so-called kurtosis. With kurtosis, well, first off, we can access with the function kurt. With the kurtosis, we are asking whether the values are actually more closer to the mean or more evenly distributed. So more or less, in other words, is the data set more heterogeneous or more homogeneous? And well, some people might be wondering to get here a negative value. That's because, well, actually, when we use the function for the kurtosis here, we are not calculating the kurtosis as it's defined in a statistics book. We are actually calculating the excess. Well, what's the difference between the kurtosis and the excess? Well, the excess is nothing else than the kurtosis minus 3. Why 3? Because we're always taking the normal distribution as benchmark. And the normal distribution has a kurtosis of 3. So if we get a negative value here, this means it's more closer to the mean. So it's more steeper in the middle. If we would get a positive value, it would be more broader. So that's the idea with the kurtosis. So here we actually have values which are more or less relatively close to each other, to the mean. Well, this also comes from the fact that we have a very limited scope. If you go back to the other set on the measures of dispersion, we see we only have a range of 4. We have an interquartile distance of 1.3. So it's a very narrow data set, and this can be witnessed here with the kurtosis of minus 0.76. And well, that's the two measures of distribution I wanted to talk about here. So here we saw in which way is the data set leaning, more smaller, more larger values. Okay, if I say more, what I mean is as compared to a normal distribution, as compared to a symmetric distribution. When I say here with the kurtosis or with the excess, whether they are more homogeneous, more heterogeneous, I again mean as compared to a normal distribution. So a benchmark in both cases, the normal distribution. Well, that's then all there is on this topic of measures of distribution. So I hope you enjoyed listening to it. And if you want to see more on the topic of Excel, feel free to visit the rest of this course or take a look at the corresponding playlist. I say goodbye and see you next time.